Welcome, ladies and gentlemen, to the Coin Republic podcast. My name is Aurora Bacharya. One thing that makes blockchain different from other asset classes is that it's not only dependent on FIIs and DIIs, not only institutional players and all the retail players. It's also dependent on developers, right? Also miners in some to a certain sense. But today we're gonna focus on developers. How are they developing on layer one blockchains and making an economy out of it, further solidifying that layer one blockchain based on which they're developing their project on? I have today RDX Works. Okay, their protocol is called Radix. They're a layer one smart contract platform, so like Ethereum, Solana, and all that. And they claim that they are the only decentralized network where developers will be able to build quickly without the constant threat of exploits and hacks, where every improvement will get rewarded and where scale will never be a bottleneck. That's actually written on their website. So we're going to have a candid conversation with the head of partnership at RDX Works Limited, the one and only Mr. Ben.
Hey, thank you so much for the intro.
So, since we are going to keep it candid, let's dive right ahead to your most addressable USP, which is user experience. Okay, how did you how did you focus on that UX part exclusively?
Okay, so you introduced Radix earlier. So Radix is a layer one smart contract platform. And we like to think of ourselves as radically different. And we're radically different because we have had this kind of laser focused on the end goal. The project, unbeknownst to many people, is actually super old. It started in 2012, 2013. And Radix has had this kind of like vision of being able to build a decentralized network that is capable of supporting the global financial system and with experiences that any normal person and any developer can easily use and easily build decentralized applications. And so having had this kind of vision of the end goal, we had to kind of like map backwards exactly what it would take in order to achieve that vision. And so the result is this kind of full stack layer one platform where each layer within the stack has been carefully crafted to work very tightly with the layer above it and the layer below it. In the same way that, say, for instance, with Apple, they control the entire stack from custom silicon to custom hardware to operating system to app store to provide the best possible user experience. In the same way that Tesla had to go deeper in the stack than just the car itself and build a network of charging stations in order to provide a user experience that enabled the electric car to go mainstream. And so Radix has looked at the final end goal and crafted this full stack that is capable of providing a user experience that your friends, family, and colleagues can confidently use, a developer experience that everyday developers can use to build production-ready, secure DeFi and Web3D apps. And it's all on a platform that will scale without compromise in a very different fashion to what we've seen before. So that's kind of what Radix is. It's a project that has had its vision on the end goal and is focused primarily on user-friendly, secure user experiences, allowing developers to build quickly without the constant threat of hacks and exploits, and on a platform that scales without friction.
Oh, fair enough. Could you identify what sort of problems are developers facing while developing their projects on layer one blockchains, and how do you I know the UX angle, of course, and you did expand on it a bit, but particularly from a developer's point of view, what sort of problems do they face of late?
Okay, so I think I see there being four key problems that developers are facing today. The first is that it's very difficult to learn how to build secure production-ready DeFi and Web3 apps. And as a result, build time is slow, and developers spend up to 80% of their time building things like validations, spending their time on like testing and audit instead of the actual functionality of the platform. So that's the first point. It's slow to build. Second point is you just have to look at rec.news or just keep your eyes and ears open for what's going on in DeFi. We seem to have billions of dollars worth of hacks every year. Every single week, there's some form of new hack. And so the problem is not that DeFi developers are not good. DeFi developers are some of the smartest in the world. The problem is that the tools that they're given doesn't allow them to be able to build secure DeFi out of the box. And so that's another problem that we solve. The third is that the user experience is poor. And so if you're a DeFi or Web3 developer, a lot of your potential users drop out of the funnel before they actually convert to being a user. And the fourth is that obviously, ultimately, transaction fees will be prohibitively high for any platform that garners enough attention and traction. And so developers need to be building on a platform that they know will scale without issue. And so to address those in a bit more detail. So why are they slow to build? Well, you can cast your mind back to the 1990s of computer game development. In the 1990s, if you wanted to build a game like Doom or SimCity or any other kind of famous game from the 1990s, you'd have to build, first of all, an engine in which your game will then live, right? You'd have to build a physics engine to define things like gravity and the fact that your characters can't walk through a wall. You'd have to build a graphics rendering engine so that the computer can actually display what's going on screen. And once you'd spent hundreds of hours building the underlying engine to build the kind of like environment in which your game can operate, it's only then can you actually then build a computer game and the things that make a computer game great, like the gameplay, the levels, the storyline. And so we are in the we're in this 1990s world of computer game development in DeFi and Web3 today. It's because everyone is building their own systems for finance, their own engines themselves inside their smart contracts. Like, for instance, if you look at like what a token is on Ethereum, a token is just a line item inside a developer's smart contract. And all the logic around how that token behaves, how you can withdraw tokens, how you can deposit tokens, all that logic is built by the smart contract developer. And so why are they slow to build? Because they're building these kind of fundamental laws of finance inside their smart contracts, and they're having to duplicate that every single time. And so casting our minds back to the computer game analogy, in the late 1990s, game engines came along, like Unreal Engine and Unity. And what they did was they provided developers an engine in which to build their game. And so they provided a physics engine where you're no longer having to have a physics PhD to build a game. You literally just get Unreal Engine out of the box and you parameterize what you want gravity to be. Because Unreal Engine natively understands what gravity is. Unreal Engine natively understands what an object is and it can't walk through a wall. And so if you're a computer game developer and you're given tools that understand the things that you're trying to build, your productivity can be massively increased. Instead of building physics from scratch, today, a game developer gets physics out of the box. And so right now, we are in the pre-game engine era in terms of DeFi. Ethereum and other platforms don't give developers tools to easily manage tokens, create tokens, send tokens, and all this kind of stuff. You have to build all this stuff from scratch. And yes, you can copy-paste a smart contract library from OpenZeppelin and et cetera. But ultimately, you are responsible for making sure everything in your smart contract is secure. And so why are developers so slow to build today? It's because they're not given the right tools, and we're in the pre-engine era of developing smart contracts. And so when Radix's Babylon upgrade happens next month, this will be the dawn of this new era in smart contract development, where developers are given an engine that actually gives them a lot of this stuff out of the box. And so their productivity is increased markedly. And so some of the kind of like stories we're seeing is that for a like-for-like implementation, we're seeing developers build on average 5 times more quickly using Scripto, our programming language, than Solidity. So for a similar type of implementation, on average, you're about 5 times quicker using our tool and our language. And so it's faster.
Okay, fair enough. Fair enough. I do have a follow-up question to that because you seem to be the most qualified person at the moment to answer it. Recently, the Curve, the major decentralized finance platform, it created a panic attack in the entire market, right? Millions of dollars were compromised out of a Viper compiler, a bug on Viper compiler. So since you guys have Scripto from that point of view as well as from the developer's point of view, how do you assess that attack, and how you prepared for that sort of an attack on your side?
Okay, so I'm going to have to caveat what I say because I've not spent a huge amount of time looking into the specifics of the Viper and Curve incidents. However, what I can say is that what I understand it to be is that it's a kind of like a re-entrancy attack, or a re-entrancy exploit is what ultimately resulted in the funds being lost, irrespective of whether the Viper compiler allowed it or not. And that is because re-entrancy is a vital enabling feature within the EVM and many other smart contract programming languages. They're built around requiring re-entrancy to be able to do certain things. And you have to manually, as a developer, turn re-entrancy off if you want to protect one of your smart contracts from that. And so on Radix, in our engine, Radix engine, re-entrancy is disabled. It's just not necessary. And so throughout the whole environment, there's no such thing as re-entrancy because our programming environment doesn't rely upon it. So it's disabled.
Yeah, got it. So do you think re-entrancy attacks could have been avoided in terms of like Curve's case?
Well, again, I'm going to caveat this because I'm not super close to the details of that particular hack and exploit. However, what I understand it to be is that in Curve's case, they programmed it properly, but there was this kind of like small unknown bug within the specific version of the compiler that used within Viper that then resulted in this actually being a vulnerability. And so unless you go through the compiler in detail, then it seems a little unfair on Curve to say that they didn't develop this properly. However, I haven't looked at it in detail, so I can't really say with much clarity. But what I can say is that re-entrancy is not enabled on Radix, and that's just one of many different kind of like features of the Radix environment. So if you just go back to that analogy, are you going to be more likely to have a bug in your game if you build your game from scratch, like totally from scratch, or if you use Unreal Engine? Like, I mean, you're much more likely, in my view, to have like a person walking through a wall by accident if you build your own custom physics engine, because Unreal Engine is battle tested. Thousands of games use it. You know you're not going to get a bug of someone walking through a wall, and if you build your game in Unreal Engine. However, in DeFi, if you have a bug, it doesn't just mean a poor game experience. It means $1 million lost or more. And so that's why we need an engine for the secure handling of assets and for developer productivity to be boosted.
Okay. Quick question about Scripto in particular. Do you identify Solidity and Viper and all of these other programming languages as a competitor? What is your USP in this case?
So Web3 and DeFi is still small. By most measures, Web3, I think, has about 0.01% of daily active internet users. I looked it up the other day. It has 0.01% of assets under management as compared to the global financial system. And it has 0.1% in terms of developers. So about 25,000-ish full-time developers in Web3 versus 25 million-ish, right? So it's 0.01% to 0.1%. So we're all early in this space. And so when you say competitor, I like to think of us as all being kind of trying to grow the space forward. So I think of Solidity as being an amazing first stab at what a smart contract programming language should be. They showed the whole industry the way as to what it would be like to build decentralized applications, decentralized forms of money on a permissionless public ledger like Ethereum. However, like the first plane or car, if you cast your mind back to the 1920s or 30s, it's not really going to be its final form. And so what we've done is we've taken a lot of the lessons of Solidity smart contract developers, and in fact, we interviewed almost 1,000 Web3 developers in developing Scripto. And we've built upon what Solidity laid as a foundation and redesigned what it's like to be a programming language. And the result is Scripto. And Scripto is very tightly integrated with the virtual machine Radix engine. And Scripto has native features for asset handling. So if you want to create an asset in Scripto, and this is just going to be quasi code, right? It's not actual code. It'll be something like .create fungible token bracket 1000. And that creates you a token with a supply of 1000, for example. Like that's a native feature of the programming environment. And so you can create tokens, you can manage tokens, you can send tokens places. We have native containers for tokens called vaults, which is where tokens live. And we have native containers for tokens on the move called buckets. And as a developer, that improves composability and it makes your life easier because you just kind of take tokens and put them in vaults, put them in buckets. And the vaults and buckets, which are native features of the programming environment, they're the ones that actually hold tokens or send them places. And buckets have to resolve by the end of a transaction. Otherwise, the transaction fails. And so you can be sure in a Radix transaction that you're not going to get lost tokens because the actual environment, the virtual machine with these native features like buckets ensures that transactions kind of net to zero and settle properly. So are you, again, going back to this game engine analogy, Scripto is like this kind of like developer interface into the engine itself. And so that's kind of how it differs with these native asset features, native access control features, and transaction and transaction manifest, which is very different to transactions on other platforms. And I can talk about that if you like as well. Yeah,
absolutely. Let you know, we're gonna unfold the technicals one by one, but for the uninitiated people who are not aware of your platform, could you quickly tell them if you are proof of work or proof of stake at the moment?
Yeah. Okay. So Radix has its own consensus mechanism called Cerberus, and Cerberus uses a delegated proof of stake system for Sybil resistance. Yeah, so Cerberus is built on top of a consensus algorithm called Hot Stuff.
Right.
But Cerberus has a bunch of additional innovations and features that enables it to be cross-shard instead of just single shard. It's a multi-shard consensus algorithm, and it's actually just recently gone through peer review in the Journal of Systems Research.
That is interesting. Let us expand on that. So Cerberus is a minimalistic, multi-shard Byzantine resilient transaction process and mechanism, if I'm not incorrect here. So how does it
say that again 10 times very quickly?
Okay, minimalistic, multi-shard. Okay. H bar community would be all over me right now. Okay, so how does it address the problems of global ordering without compromising the security?
Okay, wow. Diving into the technicals. Okay, so if you think about what a blockchain is this single state that contains blocks full of transactions. And every single node validating that or replicating that data structure every single node is holding the entire state and processing every transaction. It's what's known as a fully replicated system. And that type of system reaches a fundamental scalability limit, because if every single node is processing every single transaction, by definition, you can't go faster than a single node. You can't go faster than a single computer. And so, yes, you can ramp up the speed of that computer. You could do 1,000 transactions per second, 10,000 transactions per second or more. Ultimately, there's going to be a limit if you're limited by the speed of a single computer. And so how does Cerberus differ? Well, Cerberus was designed to be sharded from the very beginning with a fully replicated system, because by definition, you can't scale more than a single computer. And so we researched how to scale a multi-sharded system for about 7 years, from 2013 to 2020. And the result is Cerberus. And Cerberus has this kind of unique cross-shard consensus, where two different validator sets are able to communicate with one another on whether a transaction is valid, and they can come to consensus across shards. And so if you have cross-shard consensus, then if you just start with an idea where you just start with like an almost absurdly large number of shards, then all you need to do is add more validator sets and your throughput can then scale linearly. Because if everything is already cross-shard, there's no reason why throughput of the entire system should be limited to a single computer, because you have lots of different groupings of computers. And so that's the kind of basic premise behind Cerberus. It's a cross-shard or multi-shard consensus algorithm. And within the peer-reviewed paper, it was demonstrated to be able to process, under specific circumstances, millions of transactions per second.
Absolutely. If you could please send me that paper, I would definitely love to study it.
Absolutely.
I'm really excited about, like, because from the point of view that I'm getting over here, because you guys are layer one, right? With your own consensus mechanism and your own milestones coming ahead. Where does layer two scaling solutions and EVM compatibility come in the equation?
So layer two scaling exists because the layer one doesn't scale properly or doesn't scale sufficiently. So with our linear scalability, I don't believe we'll need layer two solutions because Cerberus will scale with demand. So you just add more nodes and it scales more and more and more and more. In terms of EVM compatibility, we've purposely not allowed ourselves to be EVM compatible because the EVM is a completely different virtual machine. And as I mentioned before, the EVM provides developers this kind of like ability to create smart contracts. And inside the smart contract lives tokens. And the developer is solely responsible for making sure that the smart contract containing the tokens functions properly and is secure. The Radix environment, the Radix virtual machine, is very different. It natively understands tokens as these physical objects that you pass between accounts. And so you're no longer relying upon a developer's smart contract holding a bunch of tokens. You've got this kind of like additional layer within the environment where the virtual machine is kind of holding and shuttling assets around. And as a developer, you're not programming the basic laws of finance. What you're doing is you're just parameterizing those basic laws of finance in the same way that with a game engine, you're parameterizing gravity. And therefore, the only thing you then need to develop as a developer in the Radix ecosystem is, well, not the only, but the main thing you're doing is business logic, because all the asset logic is abstracted away from you and given to you as this kind of complete tool set. And so that's why developers are far more productive, and that's why it's more secure, because the virtual machine natively understands assets as physical objects and shuttles them around places. And so we're not EVM compatible because that is a completely different paradigm to EVM. And so EVM code that would compile and run on the EVM just is not compatible with Radix Engine, and scripter code that compiles and runs on Radix Engine is just not compatible with EVM, in the same way that you just couldn't run a Windows app on, I guess, Mac OS.
So who are you partner? So because you're the head of partnership, so you're the perfect person, if I may ask, because this is a competitive space. There are so many layer ones, right? And Solana community is tight on their side. Hashgraph, Hedera has their own community. Every community is tight in their maxis on their own level, right? So
absolutely.
Any interesting partnership that we should look upon in the future?
Yeah, so our philosophy is very much on growing our grassroots developer ecosystem. We focus primarily on building those kind of foundations of people who are highly engaged and highly passionate about building in crypto. As a result, we've had more than 12,000 developers try the programming language since it was launched in early access form at the end of 2021. And as you know, the Babylon mainnet upgrade next month brings smart contracts written in crypto to the production mainnet for the first time. And we're seeing about 50 plus projects who've signed up to our Runs on Radix program, which is kind of like Intel Inside, if you remember that, which is kind of like it's kind of like a badge of quality. So if your D app runs on Radix, you as a user can be sure that you're going to have a better user experience than you might find elsewhere. And so we've had about 50 projects sign up to that, and so we're looking to see about 50 projects launch in Q4, and so that includes some seriously innovative and cool dexes, lending protocols, NFT marketplaces, bridges, so layer 0 is integrating. And so the kind of full gamut of Web3 and DeFi is currently being built. And so now is an absolutely fantastic opportunity to get involved in the Radix ecosystem, because it's only once that an ecosystem gets born, especially one that's taken 10 years of research and development. And so this is an opportunity to get in on the ground floor and either cement yourself as a kind of like primitive or standard in the ecosystem, or really just to start playing around as an early community member, using the DApps as they first start, and really just getting involved. So yeah, it's pretty exciting time for all of us in the Radix community. So to answer your question, what about partnerships? Well, we're focusing on our homegrown ecosystem, and of course, if you're familiar with the whole kind of exponential process with these 50 projects, then and word spreads about how much easier and secure it is to build in crypto, well, then that can become potentially more and more projects that grow exponentially over time. Yeah, but I've not even really spoken about user experience so much, which is probably our primary focus right now. Sorry, Saurav.
No worries, no worries. Yeah, that's your USP. That's your marketing message. I get it. I guess before we part, one thing that I can pitch in about a partnership, about an official media partner who keeps a close eye on you guys, reports about your developments. I'll promise you one thing: even if you don't make us official media partners live on air, I'm gonna keep a close eye on RDX and Radix protocol, because I hope we don't need a Rosetta Stone to decrypt all of the things that's going on over here. User experience is the key word, ladies and gentlemen, and I'm going to make sure that is mentioned on the thumbnail. Join in and send RDX some love. Ben, it's an honor to have you here. Any parting words?
Yeah, so just on user experience, you really have to try the Radix wallet when it comes out in Q4 or end of Q3. Yeah, it's really going to be a game changer, because you've probably used things like seed phrases
dates?
or had to blind sign transactions. September 27th is the launch date for Babylon, and so it's the end of Q3. And so as a user, we're going to have this beautiful mobile wallet that that actually feels much more like your Web2 banking experience, in that you won't have to blind sign transactions. You get a fully human readable transaction that you can see exactly what's going to happen before you sign a transaction. You don't have to do things like add token. On MetaMask, you've got to add token. Why doesn't my wallet know? Yeah, that goes away because we've got native assets that the platform and wallet natively understands. You've got no such thing as like a malicious token. You know how like you get stories of people getting airdropped a malicious token and you shouldn't interact with it, otherwise they could drain your wallet? That goes away because every token on Radix is native with native guaranteed behaviors. And so malicious tokens go away. And then we've got something called a smart account. So everyone's account is a smart account, which will have native multi-factor recovery. So that feature, whilst it will be live on the network on day one, it won't be going live in the wallet for a short while after.
Fair enough. That sounds pretty interesting. That's a lot of use cases that people should look upon. Are you guys active on Twitter Spaces? Where can people join in on the RDX conversation?
Yeah, absolutely. So probably the best place to follow Radix is its Twitter account, RadixDLT. And you can also join the Telegram, which of memory is Radix_DLT. But Check the description just in case I've misspoken. And we've also got a
absolutely.
Discord that is active as well.
That is fantastic. That is fantastic. So yeah, I mean, attention to all the developers. You guys should definitely take a look at this project. But Ben, it's an honor to have you. Let's stay in touch. Let's keep an eye on RDX for the future. I wish you guys all the best. Thank you for dropping by.
Thank you so much for having me.